Okay, today should be a pretty simple day for you. You've got a short video. We're going to talk about properties of addition. And when you're done, you're going to do your IXL assignments. There were 3 of them that you had for the week. You should be able to get all of them done. But the one that you're going to focus on when we're done with this is the Y11 IXL, which is the properties of addition. So you may want to jot that one down just so you don't forget that that's the particular one that this is about. So most of these properties, I think your elementary school teachers have discussed them with you. I'm going to demonstrate them both in numeric statements and algebraic. So let me write that. Okay, so we're going to have numeric statements. So numeric examples and algebraic examples. So there are 3 properties in particular that you need to know. And these properties also apply to multiplication as well. So we're going to be going through this again next time we meet, and we're going to be talking about multiplication as opposed to addition. There's the commutative property. What does the commutative property of addition look like? Well, it looks like this. A numeric example, for example, would be 3 plus 2 could be re-expressed as 2 plus 3. All we're doing is changing the order of our terms. Now obviously, if we have a numeric statement, 3 plus 2, 2 plus 3, both of these of course add up to 5 in simplest form. But the important part is for you to understand that you can add in any order you want. It does not make a difference, okay? An algebraic example of this would be x plus 2, and that is equal to 2 plus x. Again, all we're doing is changing the terms. So, let me give you a couple more. Let's say, for example, you see 3 plus 6 in parentheses plus 4. Okay, how could that be re-expressed? Well, the parentheses are one term. Okay, so what we have in the parentheses are grouped together. So if somebody asked me to use the commutative property for this, I would be looking at this addition sign. I would put the 4 over here and add that to the grouping of 3 plus 6. Once again, we know that 3 plus 6 is 9, 9 plus 4 is 13. We know that 4 plus 9 is 13. We know if we broke the parentheses apart, 4 plus 3 is 7 plus 6 is 13. We know that 6 plus 4 plus 3 is 13. Again, we can add in any order we want. But the objective is first to use the commutative property of addition. And again, I'm doing this with the grouping symbols. An algebraic example of this may look like this. I don't know, maybe you have x plus y in parentheses plus z. I don't know if you can see all the way across, so I'm going to go down with this. And that would be equivalent to z plus, in parentheses, x plus y. So again, what I'm looking at is, I'm looking at this as being a single term, and a single term that I am saying is commutative. I can switch the order, not change the outcome. Now, by the way, it looks like a 2 there. Put a little slash through it so you can see it's a Z. Why is it important? Well, when we're writing statements, it's pretty important for us to be able to have that ability to manipulate them, move things around, and not change the meaning. Okay, so those are examples of the commutative property of addition. So let's go to the next one. The next one is the associative property of addition. What does the associative property look like, and what does it mean? The associative property has to do with how we are grouping our terms in our statement. So, again, I will give you numeric examples. So we did commutative. We're now looking at associative here. So we'll do numeric and algebraic examples. Numic, that's nice. N-U-M-E-R-I-C. It's fun getting old, kids. Okay, so Here's a numeric example. Let's say we had 3 plus 6, in parentheses, plus 2. Now, whereas before, hey, you had something in parentheses and you swapped the order and you said that that was commutative. Yeah, it was commutative because I was going to pick this term up, put it over here, pick this term up and put it over there so I could swap the terms. The associative property talks about how we group our terms. So 3 plus 6 plus 2, if I regroup this and write the same exact terms in order as in the 3, the 6, and the 2 in that order, but decided to take the parentheses and instead put the parentheses around the 6 and the 2, these are identical. Now, again, how do we add? We add in any order we want. How do we do our order of operations? Oh, we have to do what's in the parentheses first. Those are our guides. Those are the rules that we use, should I say. But we're not going to violate any rules if I add this 3 to this 2 and get 5. 5 plus 6 is 11. But if we did use our order of operations, 3 plus 6 is 9, 9 plus 2 is 11. 3 plus 6 plus 2 is 8. 3 plus 8 is 11. What the associative property allows you to do is it allows you to change the grouping, okay, without changing the meaning of the statement. These two statements are equivalent, they're equal. So the important part is that we're leaving the order 3, 6, and 2 in the same order, 3, 6, and 2 in the same order, but it's the grouping that is changing. Whereas we had the first 2 terms grouped, now we have the last 2 terms grouped. As an algebraic example, perhaps I have something that looks like this. Perhaps I have x plus y plus z, where y and z are grouped together. And that would be equivalent to a statement that would be x plus y plus z, where x and y are now grouped together. So what's changed in this? Well, the order hasn't changed. I still see x, y, and z. I still see x, y, and z. What's changed is the grouping has changed. So again, these are examples of the associative property of addition. Okay. The last example I want to give you, or the last property we want to talk about, is the identity property. What the identity property states, there's an identity property for addition, an identity property for multiplication. The identity element for addition is a little different than the one for multiplication. So the identity property has an identity element, and it's our good friend 0. Basically, it's a pretty simple concept. Again, I'll give you a numeric example. I'll give you an algebraic example. So, numerically speaking, if I take the number 12 and I add to 12, 0, guess what I get? You're right, I get 12. And that is called an identity. The identity element that we're talking about for addition is 0. When you add 0 to a value, you get the same value. Now, I know this sounds really ridiculous, 6th graders, but I got news for you. 0 and other numbers, 1 in particular, sometimes are chameleons. They don't always look like 0. And we use zeros an awful lot in mathematics. 0 is a pretty powerful number. It does an awful lot for us in terms of higher levels of math and being able to solve equations. There's just a ton of things that 0 is going to give you some benefits for. So, in any event, we're trying to plant the seed a little bit early with some of these properties, and they come up over and over in higher levels of math. So take advantage of the fact that, yeah, hey, it's pretty simple to figure out, it's pretty simple to look at, and you're gonna have an easy task in your IXL, but that's what the identity property of addition yields for us. Now, algebraically speaking, maybe you have an example that might look like this. If you had, for example, let's say you had letter B is a variable, and you take B and you add 0 to it, I have no doubt that the value you're going to get from that, or the statement you're going to get from that, is equal to B. Okay? So B plus 0 is definitely equal to B. This is 12 plus 0 is equal to 12. And that again is a example of an identity property of addition. Okay. So now that you have these under your belt, I'm going to throw a few statements up here and give you a little test. And then you can tell me what the property is. So, and this is kind of similar to what you can see in IXL. So let's say, for example, I give you 3 plus x plus y. And I tell you that that is equal to 3 plus y plus x. Okay. What property would you say was just utilized? Well, hopefully you said the commutative property of addition. Now, did that have anything to do with this 3? No. This term of 3 never changed from this statement to this statement. Those 3's are the same. But what did change is the order of the y and the x. Where this was x and this is y, this is now switched order. Y has moved here and x has moved here. That is an example of the commutative property of addition. Good? Let's try another one. Perhaps you get a statement that looks like this. 3 plus m plus 4 is equal to 4 plus 3 plus m. Okay, so what do you think? Well, you're looking at this and saying, well, I see parentheses, and parentheses, and we talked about that associative property, so I'm going to guess the associative property of addition. Problem is, that's not correct. It's not associative property of addition. What's going on is this first term that has 3 plus m has now moved to a second term in this statement. Don't forget, terms are separated by what symbol? Addition, subtraction. All I ever, black pens. I'm trying to get a red pen here. I'll put this plus sign there. Once you see the plus sign there, once you see the plus sign here. All that is happening here is we've taken this term of 3 plus m that's in parentheses and moved it to this side, taken the 4 that was on the right side, moved it to the left side. So this is not an example of the associative property, rather it's an example of what? The commutative property of addition. Okay. I have 2 more, and then you guys can jump into your IXL. You should be pretty comfortable with this. These concepts are pretty simple. So, let's try this one. I'm going to give you 16 plus 0 equals 16. Which of the 3 properties are we talking about? And this one should be pretty simple for you. This one, of course, is the identity property. Of addition, with the identity element, of course, being 0. That when you add 0 to any value, you get the same value. Just to plant a little seed, well, let's think about multiplication. What do you think the identity element of multiplication might be? And it wouldn't shock me if you knew the answer. We'll save that for the next time we meet. Okay, last example. We'll throw one more up here. So let's say, for example, you see in IXL a statement that gives you 15 plus z plus 4 plus m. And that is restated as 15 plus z plus 4 plus m. And you're asked to identify which property illustrates this transformation from this statement to this statement. Well, the answer to that would of course be the associative property of addition. Why? 15, 15, z, z, 4, 4, m, m. What changed in it? The order didn't change. What changed was the grouping. What is grouped together? So in this statement, you're being asked to, if you follow strict order of operations, to identify what's in the parentheses here first, whereas in this statement, you're being asked to follow what's in here first. And again, that it's all addition. Whether it has the parentheses or not really doesn't matter, okay? But these are the properties of addition. So see if you can practice them on IXL. Let's see if you can get that SMART score up to 90. And if not, at least a bare minimum of 20 minutes, please. Thank you.